So in today's lesson in problem number 4, we did that with pencil and paper yesterday. What I want to show you is how to use some technology to solve this today. Okay, so remember from yesterday, what did we have to find? We had to find the slope and we had to find the y-intercept. And if I write an equation, or if I want to write an equation in slope-intercept form that goes through these 2 points, all I've got to do is to find the slope and the y-intercept. That's it. And once I know what those numbers are, I just plug it in to that equation. Wherever I see an m, that's what I'm multiplying x by. And whatever b is, just follows that mx. Okay? So I'm going to show you how we can find this slope and this y-intercept using technology. So I want you to cut on your calculators. And I want to find an equation of a line that goes through the point 2, 1, and 5, negative 8. Okay? So I want to tell my calculator to graph these points and fit a line through it. And not only fit a line through it, but to tell me what that equation is. So that way I don't have to do any calculations. All I got to do is know how to push the right buttons. Y'all ready? So go to your home screen. Go to New Document, which is number 1. I do not want to save my last document, so go to No. Okay? So I'm going to zoom in a little bit so you can see this a little bit better. Now, I want to enter points into my calculator. Can anybody tell me how to enter points in my calculator? Do y'all remember how to do that? When we did scatter plots, what did I have to go to? Lists and Spreadsheet. So hit 4 or just move that highlighted section to Lists and Spreadsheet and hit Enter. Either way. Now, I have x's and y's. This is an x, this is a y, so I have to have an x labeled and a y labeled. So I'm going to take my cursor into that very tip top far left cell, and I'm going to title that as my x's. So it's just like title in a table. Tab over, and this one is now my y's. Right, so I titled my x and my y. Now, this one right here, this row, always leave blank. So go down to this cell A1, and that's where I enter my first x, which is 2. Tab over, and my y is 1. All right, so hit Enter, and then move over to my second coordinate, which is 5, negative 8. X is 5. Tab over, enter a negative 8. Now you got to hit Enter, or you got to click out of that cell somehow. Okay, everybody out of the cell? Now what I want you to do is to go to any empty cell. It could be a D1, C1, wherever. Just move this little cursor to an empty cell. I typically skip a section over and go to D1. Or skip a row or column. Skip a column and just put that in D1. Now I'm going to tell my calculator to come up with an equation for this in slope-intercept form so I don't have to. So here's the important part. This is stuff you don't know yet. Hit Menu. So that way we can get our calculator to tell us what the slope is and the y-intercept. Now, from Menu, I'm going to go to Statistics, which is number 4. So I can hit 4 or just highlight it and hit Enter. And then I want to do some sort of stat calculation, which is 1. Now, I want to come up with an equation of a line in slope-intercept form, and that is number 3. So I go to number 3. All right. Now, it's going to come up and say, hey, all right, I want to do a linear regression, so come up with a line in slope-intercept form. From what list? From our x list, we titled that x column to be what? X's. So our x's that we titled in that spreadsheet was x. We didn't call it anything else. I didn't call it time. I didn't call it temperature. I called it x. And then what did we label our y column to be in our table that we made from our spreadsheet? That was y. So I tab over, and then now just hit Enter. Hit Enter, and there's the equation. Now it's not exactly the equation, but it does tell me what m is. What's m? What's the slope? Negative 3. See, what is the y-intercept? Remember, b is the y-intercept. What's the y-intercept? 7. Didn't we get that yesterday? So what did we get the equation of this to be? Well, you just substitute in your negative 3 for your m, and your b is a 7. So my equation would be negative 3x plus 7. Okay, if you didn't get it the first time, we're going to do it again. But I want to show you more information now. See, I don't see anywhere where it says that equation, right? Do y'all see where it says the equation y is equal to negative 3x plus 7? Anywhere on your calculator right now? No. It just told me two things. What did it tell me? The slope and the y-intercept. Do y'all know your calculator already graphed this for you? There's a graph already graphed for you. You just have to call up the graph. So how do I call up the graph of this equation? This right here. Our calculator's already got this plugged in for me. How do I look at the graph? Here's what you do to look at the graph. Hit Control, add a page, which is doc. Control, add a page. Look, it added you a page. It's the second page of your document. And I want to look at the graph. Guess what? The graph is already there. I just have to add the graph. Hit 2. And it's there. There it is. Y'all see the picture of it? I don't either. It's there. It's the first function rule. See how this says F2? It's saying that's the second equation. Where's the first one? It's right above it. So click up. Just take this little keypad and push it up once. And there's the equation. Look, isn't that the same equation we have? Y, or f of x, equals negative 3 times x plus 7. There's the slope-intercept formula. But why don't I see the picture of the graph? Because see this little box right there? It's not checked. So I move my little cursor over there, and I can just click on the box, or I don't have to move my cursor anywhere. All I have to do is hit enter. Hit enter in your calculator right there, and it'll graph it for you. So hit enter. Do y'all see the graph now? So what if I said come up with a table of values for this function rule? Hit Control T. Now you know everything. You know all the tricks to pass the EOC. I just showed you how to cheat on it. We don't have to do that with pencil and paper. You got to know how to push the buttons. Right? There's the table. There's the graph. What's my function rule? Look, Control T. Right? How do I come up with my function rule? Just hit Tab and go up. There's my function rule. There's my function rule. Right? I told you this is one of the most asked questions on the EOC, and all of it is by a push of a button. We can find these answers now, right? Let's try that again. What equation did we get for B yesterday? What was our equation yesterday? Y'all tell me. We already did these notes yesterday, so what was my function rule? Wasn't it 1/2 x minus 3.5? Or what was another way that I said you could write that yesterday? 0.5x minus what? It's either one of those two, right? Let's get our calculator to do that for us. So, if we don't have it perfect yet, we'll get it now by going to, we're going to start over the whole process. So go to your home, hit home, go to new document. Do I want to save this last one? No. All that does is just erase everything for you, right? It gives you a clean slate. Now, what do? Y'all tell me what to push. I've already done it one time. Y'all help me out. How do I add these points? Do I add a graph? Add list and spreadsheet. Very good, which is number 4. Go up here and title this as X for my X point and a Y point. So I need to label this X and Y. For my X coordinates, tab over my Y coordinates. Do I put my first X right here? Do I put it up here? No, always skip this row. Put it right there in the A1 cell. So my first X is 3. My first Y is negative 2 with that 3. My first X is a 1, then negative 3. Now I've got my points entered. What do I do now after I enter these points in? Go to a empty cell. It doesn't matter where you put it. You can put it here. I like putting it over one. Just put that. You could even put it down below. You can put it anywhere you want. I just usually put it at the top, and I skip a column, and I put it that D1. And then now what do I do to come up with a linear regression, which means come up with a linear function in slope-intercept form for this? To figure out what is the slope, what is the y-intercept. How can I get my calculator to tell me that? What do I hit now? All your functions are always on menu, so hit menu. Do y'all remember what I hit next? Statistics. Then I need some sort of calculation, stat calculation. And which one do I want to do? I want to do a line in, what is this? See how it even says mx plus b? That is slope-intercept form. So I just hit 3. Now I have to title my x list. What did I title it? X. So here's your X button right there. X is X. Right? And then tab down. Y is Y, which is right there. So I'm going to put Y as Y. Tab down. And then now just hit enter. And I'm done. What's my slope? What's my slope? 0.5. What's my y-intercept? Negative 3.5. It should be a 3.5. So what's my equation? Y is equal to my slope times x minus my y-intercept. That's it. Isn't that the same thing we got yesterday? Is this easier? All right, so let's come up with this last one and then we'll move on. Okay? How do I come up with an equation of a line in slope-intercept form that goes through these points? Once again, last time, hit home. I'm going to go faster now, so y'all keep up. Y'all try to work ahead of me. New document. Do not save my last one. Add a list in a spreadsheet. Title my X column as X's. Make a table for my Y, so my Y column is Y. Leave this one blank. Begin in cell A1 and enter my first X, which is negative 2. My first Y is 4. All right, move to my second X, which is 3. So notice how my X's are lined up. And my next Y is a negative 1. And then find an empty cell. Hit menu, statistics, stat calculations, and number 3, a linear regression in slope-intercept form. Enter. X is X, Y is Y. Hit tab and just enter, and there's my equation. Alright, so my slope is negative 1, my y-intercept is 2. So if I know my slope is negative 1 and my y-intercept is 2, can y'all tell me the equation in slope-intercept form? Negative x plus 2. That's my m value and that's my b value. Now my calculator will do that for me. Y'all remember how to get a picture of the graph? How do I add the graph? Sit up, please. Hit Control, add a page. And we're going to add the graph, which is number 2. Right? It's already there, but it's not the first. It's not the second one. It's the first one. So go up 1. And to graph it, just hit enter. And there's the graph. Did I go too fast? And there's a table there too. You want to see the function rule? The function rule is there. Go to tab. There it is. Negative 1x. Negative 1x plus 2. Just like we wrote. Except you'll never see it that way on the EOC. What did I say? Anytime you have a negative 1x, it's really the same thing as negative x. Because negative 1 times anything is that thing itself. But it's a negative times an x, which is a negative x. Plus 2. That's the way you'll see it on the EOC. That will help you now, right? Does that help? Okay. So I'll show you a little bit of technology throughout the year that'll make some problems easier. Maybe that will. Here's problem number 5 for your notes. How do you graph this? How do you graph a linear function? Well, it's not hard at all if I know where the slope is and the y-intercept. What's the y-intercept of this? Can anybody tell me? Where does this cross the y-axis? 4. So to graph this, I put a dot, a point at 0, 4. The y-intercept is where this graph crosses the y-axis. It crosses at a positive 1, 2, 3, 4, so put a dot there. Now, how do I find another point on the graph? Use the slope. What is the slope of this line that goes through that point right there with that y-intercept at 4? What's the slope of the line? Negative 3. Negative 3 is the slope. Now, what's another way of writing negative 3? I can write it as a fraction, right? Negative 3 over 1. Isn't that the same thing as negative 3? And so slope is my rise over my run. So if I have a point on the graph that crosses the y-axis at 4, I can use the slope to find other points. My slope is negative 3 over a positive 1. So from this point, to find another point on the graph, I rise down. Why down? Because it's negative. 1, 2, 3. And then run to the right or the left. Y'all tell me. Well, if it's positive, it is, what is it? Right. 1. There's another point on the graph. I can find other points. From that point, I rise down 3 again. 1, 2, 3. Run to the right. 1. There's another point on the graph. I could do this all day long. To find another point on the graph, rise down. 1, 2, 3. Right what? 1. And then to make a graph of this, I just get my ruler and connect the dots, and it should go through every point perfectly. But we have a little bit of human error on this. What's my human error? I didn't do this on graph paper. This is just my handwritten coordinate plane. But if we did it correctly, you should be able to go down 1, 2, 3, right 1, and be on the line. Down 1, 2, 3, right 1, be on the line, and so forth. And that's how easy it is to graph one of these once it's in slope-intercept form. So I don't have to make a table of values, did I? Did you have to make a table of values and then plot all those points? No, these points are here. What? Here's one point. Where is it? It's at 0, 4. Where's this point here? It's at 1 what? 1. Where's this point here? Well, this is at 2. Where would that be? Negative 2. That is a table of values, x and y. And these points, instead of having to calculate it, I can find those points and just list them in a table. 0, 4, 1, 1, 2, negative 2. And if I want to check the math, if that's a 0, what's 3 times 0? 0 plus 4 is 4. There should be a point at 1, 1. So if that x is a 1, what's negative 3 times 1? Negative 3 plus 4 is 1. If I plug in a 2, what's negative 3 times 2? Negative 6 plus 4 is negative 2. You see how the calculations work out too? I didn't have to calculate a darn thing if I just know that that crosses the y-axis at 4, and that slope will help me find other points that are on the table that are also on the graph. Hopefully we see those connections, because I'm not going to do that again. All I want to know now is, can you graph this function without using the table? You don't have to guess 2 negatives, a 0, and 2 positives. How do we graph it like that? Put a dot where? At the y-intercept, which is negative 1. Use the slope, which is 2, but that's the same thing as 2 over 1 to find other points. Now remember, slope is the vertical change, which is called rise, over the left to right change, or horizontal change, which is run. So from here, to find another point on the graph, what do I do? Rise up 2, because it's positive. Run to the right 1. There's another point. Rise up 1, 2, right 1. There's another point. Rise up 1, 2 to the right 1. There's another point. And then get your ruler and connect the dots. And there's a visual picture of that. Y is equal to 2x minus 1. Guys, this is way faster than even plugging it into your calculator. Okay, if you know that. Once again, this is my slope in problem C. So that's my rise over my run. And then this is my y-intercept. So to graph this function, look how fast it is. Put a dot at negative 1, 2, 3. There's a point on the graph at negative 3. use the slope, which is 1/2 to find another point. Now that's a positive 1 over a positive 2. So I rise up 1, run to the right 2. Rise up 1, run to the right 2. I could do this all day long. But really, to graph a function, I just need 2 points. I could have done it with just these 2 right here. Right? That's it. But I found several other points, or I found another point just to be more accurate with my graph. And then I just connect the dots with a straight line with your ruler. Pretty easy. Isn't that a lot easier than what we did in chapter 2, where I said, all right, you got to pick a -2, a -1, a 0, 1, and a 2. Plug it into your function rule and come up with the y's, and then plot the points and then connect the dots. Wouldn't this be a faster way of graphing? And that table corresponds to these points on the line. This table would correspond to these points on the line if I would extend it out forever. You got it? Okay, let's go to an application problem of when you would use this. Here's a physics problem. This is dealing with scuba diving. Okay? It's kind of like scuba diving. If you ever go down, anybody ever swam down like really deep in water and you feel pressure in your ears kind of pop? Okay, there's pressure on your body. Okay? And even when you go up really, really high sometimes, if you're ever flying an airplane, some people have trouble with their ears in the airplane, and they got to repressurize their ear by chewing gum or swallowing and stuff like that. Well, we have pressures on our body. If we go down deep underwater, we have the pressure of the water on our body. And likewise, when we go up in the atmosphere, we have different pressures put on our body. So right now, typically when we're sitting here at ground level of 0, we have 1 atm of pressure on our body. And it's just a unit of measurement that's dealing with the pressure on your body. So here's the question. Water pressure can be measured in atmospheres, which are called ATMs. Use the information provided below to write an equation that models the pressure Y. So Y is dealing with the pressure at a depth of X meters. So whenever I go down so many meters, I have more pressure put on my body. Then let's graph it. So I need some information. Here's the information I need in order to set up an equation. At 0 meters, the pressure is 1 atm. So if I don't go anywhere, if I'm sitting right here, and if I don't go down at all, I've got 1 atm currently on my body. So that means when time is 0, or when the depth is 0, I begin with 1 atm on my body. That is my y-intercept. This is my b value. B is 1. And then it says, as you swim deeper in water, the pressure on your body increases by 1 atm per every meter. I go down 1 meter, I have 1 atm. 2 meters, I have 2. 3, I have 3. 4, I have 4. So I get additional atms added as I go down. So that is my slope. It's 1. Okay, so what's my equation? The pressure, which is P, but we're not using P for pressure. What is used for pressure? Y. That pressure Y is equal to, how is pressure being added? 1 atm per each meter that I go down. So if I go down 1 meter, it's 1. 2, it's 2. 3, it's 3. And what is represented with the meters? It is X. It's 1 atm per each meter, so it's 1 times X. Or 1 times the number of meters I'm going down. Plus the pressure that's on my body when I'm at a depth of 0, or I haven't gone down at all, which is 1. There's my equation. There's my function rule. Now, I don't like the way that looks. We don't write 1 times X. What's the best way of writing that? 1 times X is X plus 1. Mathematicians are kind of lazy. There's no reason to put a 1 there. Right? It means the same thing. If there's no number in front of the X, it's a 1. Now, I don't like this right here. See how this is 10, 20, 30, 40, 50? Let's just change it to be easier numbers like 1, 2 to be easier to graph, a depth of 3, a depth of 4, and a depth of 5, and then graph it. So let's do that. Well, it's easy to graph. What's the y-intercept? 1. What's the slope? 1. So to find another point, I rise up 1, run 1. Rise up 1, run 1. Look how easy it is to graph these without doing any calculations. Or I could do the calculations. If I'm at a depth of 2, 2. What's 1 times 2? 2 plus 1 is 3. See, I'm at 2, 3. That's the order pair 2, 3. Or I could just rise up 1, run 1. Or if you like doing the calculations, that's 3. 1 times 3. So if I'm at depth of 3 meters, 1 times 3 is 3 plus 1, which is 4. See, I'll still get the same points. Now, let me ask you a question real quick. Would this be a series of dots, which is called a discrete function, or would it be a continuous function? So do I connect the dots with a line, or do I just leave it as dots? Why would I connect it with a line? You're right. It's a line. It's a continuous function. Why? Can anybody tell me why? Yeah, I don't have to go down. I can go down half a meter. I can go down a quarter of a meter. I could just barely have my head maybe that far under the water, a couple inches. Right? So I'd have to include all those fractions and decimals in between. So it's a continuous linear function. All right, what is the domain of this function real quick before we go to the last problem? What are the x's on the graph? What do my x's begin in this model? At a depth of 0. So it'd be x such that x is any number greater than or equal to 0. That is an EOC question. It will always be on there. And what's the range of this function that we graphed? What's the lowest y value on this graph? 1. What's the highest y value? I don't know. It goes up forever. So the range of this would be y such that y is any number that's greater than or equal to what? 0. Make sure you know domain and range. And make sure you know that this is a continuous function. You will see that several times throughout the course of this year. Okay, last problem. Can you come up with a equation for how a plumber's getting paid? A plumber charges a $60 flat fee for repair plus $35 per hour. Tell me an equation for how much you're going to have to pay him if he comes work so many hours. Anybody know? The cost is equal to, what does it cost, right? So what's the cost, all right, for the plumber? Well, it would be his what? Flat fee, whatever that flat fee is, plus his rate, right? So he's being charged a flat fee of $65 just for showing up. What is that? Is that my slope or is that my rate? And if I think about this as slope is a rate of change. The rate of change is how his rate or how much he's getting paid is changing per hour. It's $35 per hour, so that would represent my slope. And this flat fee is what you're going to pay if he just shows up, right, and drives to your house and goes, hey, I'm here for that call, and you go, oh, I don't need you, I fixed it myself. He says, well, you're going to pay me $65 because that's my flat fee. I've already told you that on the phone, and I showed up, so you're going to pay it. Right? Because that's what, I guess, how he's getting paid. So what would my equation be if it's in slope-intercept form? Well, this flat fee is my y-intercept or my b amount, and this rate of change, and that's how he's getting paid per hour, is your slope. Right? So if I want to use it in terms of y and x, so I can graph a visual picture of it, my charge or my cost, which is y, that's going to cost me, is equal to what? $35 per hour plus my flat fee is $65. So how do I graph that? Well, it's not going to be a perfect graph, right? But we can get it pretty close. If he shows up and works 0 hours, what's the pay? About $65, about right there. What if he shows up for 1 hour? What's the pay? 35 times 1 plus 65 is $100. What about for 2 hours? That'd be 35 times 2, which is $70, plus 65 would be $135. Somewhere about right in there. If I continue this out, that's the same thing as rising 35, running 1, rising 35, running 1, rising 35, running 1. Right? Rising 35, running 1, and so forth and so on for each hour that he's working. Is this a continuous function or a discrete function? If I work for half of an hour, do you think I want to get paid for that?
Yes.
I do. Don't you? If you showed up and worked 2.5 hours, do you only want to get paid for 2 hours, or do you want to get paid for the time that you're working? I want to get paid for that half hour. If I work for 15 extra minutes, I want to get paid for that. I want to get paid for every fraction of an hour that I'm working. So I want to get paid for those halves and the halves of the halves and the halves of the halves until it's a straight line. So what type of function is this? This is a continuous function. Y'all follow? So what's the domain of this function and the range? And we'll stop there. The domain are the x's that this guy could actually work. That would be x such that x is any number that's what? Can you work negative hours? No. No. So it would be any number that's greater than or equal to 0. What about the lowest that this guy's going to get paid according to our graph? $65, and he can get paid anything above that. So this would be y such that y is greater than or equal to 65. Make sure you got that in your notes. I'm going to check your notes real quick, but your homework is Math Excel 3. And that's going to be due, okay, in 2 days. So next time you see me, that should be due because we don't come back to school until Friday, until Tuesday. You got it? Okay.